0. There are 2.
Well, hi everyone. I'm really happy to be here today. I see some familiar schools out there, so welcome back. And I also see some new schools, so I'm excited that you guys have joined us. So I'm going to tell you a little bit about myself as I bring up some videos that we're going to see later on. So I've always been interested in Mars, and not only that, but space as a whole. So when I was in college, I went to the University of Arizona. I was able to join an internship which was exploring the polar regions of Mars, and that was called the Phoenix Lander. And so on this internship, I worked on this camera that you'll see at the bottom of the slide. And it was really, really exciting to be able to be on a mission and work with scientists and engineers. And that's what led me to my job here at the Johnson Space Center. And this is where I work with Paige. And now not only am I involved in doing research in the lab, but I'm also been able to work on the operations with the Mars Science Laboratory, and that's the Curiosity rover. So that's been really exciting to work with that and continue exploring Mars. So that's just a little bit about myself, but let's move on to our main event today. And we're talking about roving Mars and all the vehicles that we've sent to Mars to explore the areas. So let's look at what we've done in the past and what exploration vehicles we've sent. So I'm going to point out a few of these orbiters over here. So we started exploring Mars in the 1960s, where we sent some orbiters to fly by and take pictures. And it wasn't until the mid-1970s that we also sent orbiters, but we sent the Viking landers to Mars. And we were able to explore the surface of Mars with these two landers for quite a while. But it wasn't until the 90s that we returned to Mars with a few more orbiters and a rover called Sojourner, and we'll talk a little bit about that later. And ever since then, we've been exploring Mars by sending orbiters to Mars and a suite of rovers and landers. So it's been really exciting the past decade or two as we've been able to really explore the Martian planet. So this is just a quick slide to kind of explain the difference between rovers, landers, and orbiters. And our top picture here, this is an orbiter, and it's very similar to what we have orbiting Mars, our satellites that we send up for communications and to take pictures. Every time you guys use Google Maps or try and look at Google Earth, those were all images taken from orbiters, and we send those types of exploration vehicles to Mars too, that orbit around the planet, take pictures, and send it back to us. We also have landers, and landers are really cool. They don't have wheels, so they can't go anywhere. Wherever they land is where they explore. And here's a picture of the Phoenix lander. As I said earlier, we had two other landers, the Viking landers, that weren't able to move around but are able to explore the environment where they land. And then we have rovers, and here is an example of the Spirit and Opportunity Mars exploration rovers. And just like it sounds, they have wheels and are able to drive around and explore different parts of Mars away from their landing site. But just how do we get these vehicles to Mars? It's a pretty complicated process, and depending on what we're sending, it really defines the process in which we make them land on the planet. So let's look at a quick video and see how we are able to land on Mars. So that was just a quick video to show you that there's different ways in which we send our exploration vehicles to Mars. So the Mars exploration rovers, Spirit and Opportunity, along with Pathfinder and its rover Sojourner, use this airbag system. And these airbags aren't the size of the bags that are in your car. These are huge. Sometimes these balloons can be as tall as a person. So you can imagine it takes quite a bit to send those vehicles to Mars. And the MSL rover, Curiosity, used the sky crane system to land on Mars, and that was the first time it was used. And our other landers typically use this thruster system, which the video showed us. So there's a bunch of different ways we can get to Mars. So let's take a look at our rovers and kind of see how they compare in size. So this little guy over here is the Sojourner Rover, and he was sent to Mars in 1997. You can see all of the rovers have 6 wheels, and the Sojourner Rover and the Mars Exploration Rover have solar panels to power them. So the Mars Exploration Rover is quite a bit taller and bigger than the Sojourner Rover, but not as big as the Curiosity Rover. The Curiosity Rover weighs about 3 times as much as the Mars Exploration Rovers and is very tall. In fact, you would have to be about 7 feet tall to look eye to eye with the MSL Curiosity Rover, whereas you could probably come up and look eye to eye with the Mars Exploration Rovers if you were about 5 feet tall. So I have a question for you guys, and this will be our first interactive question. Of all the rovers that we've seen, which one do you think has traveled the longest distance on Mars? And we have here the Sojourner Rover, which explored Mars for about 83 days, and then Spirit and Opportunity, who have been there for several years, and the Curiosity Rover, which has been there for a few months. So in the chat window, let us know which rover you think has traveled the longest distance.
And you can let us know the rover name or A, B, C, or D, but also include what leads you to your conclusion. So think about it, and perhaps those dates will be helpful for you. Which do you think has traveled the longest distance, and what leads you to that conclusion? So we're seeing a lot of answers come in. Some of you are saying Curiosity. It has been on the surface for a long time and may move faster than the others, so that's come in from Evergreen. Evergreen, another group from Evergreen is saying C, Opportunity, because it has been there the longest. Showalter thinks Opportunity because it is not damaged and it is a rover that continues to be on the move. Lewis F. Mayer says Opportunity as well, and because it's been there the longest and it has wheels and it looks more modern. Very interesting, so I'm going to give a few more moments as I look at some of these other answers. Queen Creek has also said Opportunity because it's been there the longest. So time frame certainly seems to make a difference. Now McClary in Delaware, McClary Elementary says either Spirit or Opportunity, basing that on time. So your answers are really great, and what I want to even comment on as well is the fact that reasoning it out is an important part of science. So Sharif, what do you think?
Wow, those are all really great answers, and just like Paige said, the reasons behind them are just really great. So our answer is Opportunity. This rover, as you can see in this little picture, has traveled farther than any of the other 3 rovers on Mars. So time has a lot to do with it, but just as you can see, Spirit and Opportunity have been traveling Mars for about the same time, although Spirit is no longer working and stopped moving around 2010. But Opportunity has driven quite the distance, about 22 miles, which is really crazy. That's really far. So let's see how we designed these rovers. We saw an image before that compared all 3, and you know, engineers at GPL have been designing these rovers for many years, especially in the 60s. But I have a quick little video to show you what early rovers started to look like. So let's check this out. So that's an idea of what the early rovers that they were designing for the Mars and lunar missions looked like. So it looks a little funny compared to the rovers we see, especially if we see this rover up close. You can see we have one camera here and this tall antenna, which is used to communicate to the people driving the rover. So things have changed quite a bit since the 1960s. And here's what are a series of rovers called the Rocky rovers. And this is, these rovers were designed in the 70s and 80s, and if you look at this one here, it sure looks a lot like the Sojourner Rover. And that's exactly what it is. These were all early prototypes for rovers that we were sending to Mars. And that leads us to our Sojourner Rover. This was our first rover on Mars. You can see here it has 6 wheels, and this platform on top is a solar panel which was used to power it. And then it has an antenna which it used to communicate with a base. So it actually landed, you can see its lander back here, drove off a ramp, and is able to communicate back to this lander base with this antenna. Now here's a picture of, there was a camera on the base that took pictures of Sojourner as it was traveling around Mars. And you can see it here, it's exploring this big rock named Yogi. And on this rover it had a scientific instrument which could tell us the chemical composition of certain rocks and soils that it explored. Now, the Sojourner rover was only supposed to last for 7 days. But guess what? Just like all of our other rovers thus far we've sent to Mars, it's far exceeded its expectations. And in our next one, I'll show you exactly what it did. So for 83 days, the Sojourner rover explored the surface around its lander. And this is kind of a funny looking picture, but imagine that you're standing right here in the middle and had a camera with you. And you took pictures as you turn around. And that's exactly what the camera on the lander did. So the Sojourner rover drove off its platform here, explored rocks over here, and then made its way all the way around, exploring different places around the lander. Now, because it used an antenna, it couldn't travel very far. So that's why you see it only in a circle here, rather than some of our other rovers who have gone great distances. And that brings us to one of those rovers who's traveled really far on the Martian planet, and this is Spirit. Spirit was the first Mars exploration rover to land and has been able to bring us some really great science. So here's a traverse map, and a traverse map is basically a map from orbit that shows you the path that Spirit has traveled along its journey on the red planet. And you can see that it's gone to craters, it's traveled across these Martian plains, explored the Columbia Hills, and then finally explored a place called Home Plate. But just how do rovers drive on Mars? We saw the Sojourner rover couldn't travel very far, but then we have the Spirit rover who's traveled really long distances. So let's see, I have a video here for you guys to see how we drive on Mars. so that's how engineers and scientists are able to explore Mars through rovers. And so there's different ways for rovers to travel. So like you saw in the video, they can tell it to go to a certain place, or they can tell it to go to a rock and it will find its way there on its own. So that's how Spirit, Opportunity, and the Curiosity rover all drive on Mars. So on its journey, Spirit has done some really, really great science. And this was one of the images it took from its camera. And here's a quick question for you guys. Do you know what these bright objects that Spirit imaged in the Martian sky are? So we have two objects that are really bright, just like if you were looking at our nighttime sky. And I'm wondering if you guys know what these are.
So in the chat window, give us your thoughts on what you think these objects are, thinking about what you might see from your own backyard in the evening. But what would you be looking at if you were on Mars looking at this? So Queen Creek says planets or moons or stars. From Evergreen, we're hearing the Sun and Earth, or Jupiter and Saturn. Evergreen has also thought that the larger one might be the Sun, and perhaps the smaller one is our home planet, or maybe Earth or Venus. Showalter is thinking we could be seeing the galaxy or planets. Easton Elementary says, is it maybe the Sun and Earth? These are some interesting thoughts. North Richland Middle School here in Texas says could be the two moons of Jupiter. Chapley School in Mr. Weatherhead's class said moons of Mars, so that's a second one there. So we're getting some moons, Sun, Earth, Earth and Moon. Springbank, our group from Canada, says maybe Earth and a moon. So some really interesting thoughts. And I had no idea myself. So, Cherie, what are we looking at here?
Those are all really, really good ideas. And just like if we go into our backyard here and look up at the sky, we can see the moon, we can see stars, and we can even see planets. So all of your guesses are really, really great. But if you were standing on Mars, this is what Spirit imaged. It imaged its own two moons. So Mars has two moons called Phobos and Deimos. So when we look into our sky at night here on Earth, we see our moon. And this is exactly what Mars, the Spirit rover, saw when it looked up into the Martian sky. You can see these specks in the background, and I bet those are stars. And I really like the answers that you guys gave. They're all really thoughtful. And you know what? I think this is really cool that we can see just exactly what Spirit is seeing at night. So really, really great answers out there. So Spirit also took another image as it was traveling across Mars, and this one looks like it was just before sunset, and there's a little speck here. And just like we talked about, we can see other planets here on Earth. Well, if you're on Mars, you can see the planet Earth, which is really neat. So that's the first time that our planet has been imaged from another planet. So really cool, the different things that Spirit has been able to find. Now, one of its most significant scientific finds was actually an accident. And as some of you know, the Spirit rover had a broken wheel. And so the entire time it was on Mars, it actually drove backwards and dragged that wheel along. And one part, while it was exploring, it drove the wheel across an area that was a little sandier, and it dug deep into that sand and exposed this bright material. And what scientists ended up finding out was that this is big evidence that there was water in the past of Mars. And so this white material that it found is a hydrated silica, which is a type of mineral that has to form when that forms only when there's water. So it's really neat. Even though we had a broken wheel on Mars, it actually turned out to be one of the most one of the best scientific instruments that Spirit has. Another problem that the Mars exploration rovers have seen is that there's dust. And Mars is a really dusty place. They can have global dust storms, so some of you in Arizona probably know what dust storms are like when there's just dust covers the sky and you get a layer of dirt that just forms on top of everything. Well, that happens a lot on Mars, and you can see that this dust gets laid on these solar panels. And it's even hard to see the rover in this image. But the problem is that when our solar panels are dusty, there's less power that we can get from the sun. And so every once in a while, these our solar panels are cleaned off. And let me show you the way that they're cleaned off. By dust devils. And if you guys look out into the desert sometimes, for those of you that live in those states that may have seen dust devils, it's almost like a vacuum cleaner for the exploration rovers. And so these dust devils come by and it just sweeps the dirt right off those solar panels. And here's an image of what it looks like after a dust devil passed by the Spirit rover. So it's pretty cool that we have our own little vacuum cleaner on Mars. Now, Spirit had some problems when it ended up getting stuck in this area while it was exploring a place called Home Plate. And it's a little hard to see in this image, but you can see this top layer looks like it's a little crustier, which that's what the scientists and engineers thought, is that the rover was driving along a place that was pretty firm, but sure enough, it dug into a place that was really, really sandy. It's almost like if you were walking along the beach, really fine sand, and you put your foot into it and got stuck. That's what happened to the Spirit rover. So here's kind of a little image to see just how hard it is to move into this sand. So this is a series of images put together, and you can see the wheels just have a really hard time getting through that sand. Well, Spirit had a hard time getting out of its sand trap, and so that's what led to the Free Spirit movement. And this was where scientists and engineers tried to find out what the sand was made of and maneuver and find out the best way to maneuver the rover outside of this sand trap. So let's see how the engineers and scientists actually put a plan together to free Spirit.
So science isn't always sometimes just about doing science. There's a lot of problem solving involved as well, huh, isn't there, Cherie?
There sure is, and the scientists and the engineers have to work together as a team to find out how they're going to solve their problems. And so there's a great group and a great collaboration that exists every day while we're trying to maneuver these rovers on Mars. But unfortunately, the free spirit plan didn't work. But like our rover driver Scott said, it was like parking at Disneyland for the scientists, because they were able to explore all of the places around the rover and really made some really cool scientific findings. So even though Spirit ended up being stuck in that place and later didn't have enough power to survive the Martian winter, it was an awesome rover that really gave us some really great scientific data on Mars. So let's look at our next rover. This is Opportunity, and it's the same type of rover that Spirit is, and landed about a month later on Mars, and it has traveled, as you saw on our slide earlier, the furthest distance that a rover has on Mars, almost 22 miles. And along its way, Opportunity has also made some really great scientific discoveries. So one of the first place that Opportunity drove up to was called Burns Hill, and this is an outcrop, and an outcrop is what geologists like to call a place where rock is exposed. And you can see here there's all these lines, and scientists believe that the rocks here were deposited when there was water flowing. And so here we've seen Spirit has found evidence for water, and so has Opportunity. And while it was here exploring this cliff, Opportunity took a picture. You can see kind of the rocks of that cliff in the background. And I want to ask you guys, what do you think Opportunity imaged? So in the chat window, give us a quick answer of what you think Opportunity is seeing on Mars.
So let's see what thoughts you have about this one. And already we've got some answers from Evergreen saying perhaps clouds or clouds of carbon dioxide, which is what the atmosphere of Mars is made of, carbon dioxide mostly. They're also saying clouds in the sky or with the sun in the background. Louis F. Mayer agrees with the whole idea of clouds, as does Queen Creek. And McClary mentions that it could be silt, sand, or dust. Even Shapley School and Mrs. Voltaire's group says dust storms or dust clouds or dust devils. So we're really getting from a lot of groups, including Springbank Community High School, this whole idea that there could be dust or dust clouds or dust storms or sandstorms. So what are these things, Cherie?
Oh, those are all really, really great guesses. And what Opportunity was able to image are clouds. And just like we have clouds here on Earth, these are cumulus clouds on Mars. And so it's really neat to see all of the comparisons between Earth and Mars that we've been able to learn while the rovers have been exploring the surface. So let's take a look at something else Opportunity was able to find. And this looks a little funny. And we have the surface of the ground around here, and then right in the middle we have this bright white type of vein. And this ended up being a mineral called gypsum. And scientists believe that at one point when Mars once had water on its surface, this type of mineral was formed. And gypsum is something that can only be formed underwater. And there we go again. Opportunity finds some more evidence for a watery past on Mars. But Opportunity has also found some really cool things. And one day while it was looking around and driving to its destination, it found this funny little rock. And scientists asked themselves the same question I'm going to ask you guys. So what about this rock looks different? And what type of rock do you think it is?
So we're checking your observation skills here. So what about this looks interesting? What characteristics? What do you notice? What do you observe? And then the second part of that, what type of rock do you think it might be? And so observation skills are very important in science, and so we're going to test some of yours. So we have some from Evergreen saying pumice or a meteor. Queen Creek says it's shiny, great observation. Lewis F. Mayer says that there's holes in it like pumice. Easton Elementary says it could be igneous. Obsidian or pumice from Evergreen we're getting. Showalter in Pennsylvania says possibly a metamorphic rock. It looks like coal or a meteorite. McClary is commenting that the colors of the rock look interesting. And it's interesting, Evergreen is saying air bubbles and the color are some of those observations that make it look interesting. In addition, they say less smooth and it has holes in it. Lewis F. Mayer says maybe it's a meteor. We've heard a couple of groups maybe saying that. Let's see. It looks eroded like a volcanic rock. Shapley School there in Maine says looks like a meteor, crater type dense. Looks smooth, perhaps caused by water. And those observations are really, really good. And so they help the scientists, along with data, give them an answer. And Showalter says the rock looks gray and very smooth. So Cherie, tell us a little bit about this rock, and great answers there in the chat window.
Oh, you guys are, I think we have some scientists that are just on their way to being really great Mars exploration scientists, so really great observations. And the scientists noticed that, like some of you guys said, there's holes, and it does look shiny. And what they thought about this shiny part is that maybe it's more of a metallic type. And so this looks a bit different from the other volcanic rocks we've seen on Mars. And a lot of you guys said pumice, which is really neat. And pumice is a type of volcanic rock that also has holes in it. But when the scientists found out and did some scientific observations, they found that this was a meteorite. And it's the first meteorite that was imaged on another planet. So really cool things. And you guys are observers just like the scientists were who were working on the Opportunity rover. So a lot of you guys probably know what these are, and this is one of the biggest findings of Opportunity, and these are called blueberries. And although they aren't real blueberries, they just kind of look like them for their size and shape, and even their color has a blue tint, which you can't really see here from this black and white image. But scientists found that these little spherical objects all around one of the places that was really close to the landing site. And also were able to determine how they were formed. So these are made of a mineral called hematite, and on Earth we use our laboratories, just like we have at JSC, to find out how these different objects were formed on Mars. And so by doing work inside our labs here on Earth, we were able to find out that these were likely formed when water was present. And it's really neat to see that we can kind of explore Mars while we're there with rovers and here on Earth. Now, very recently, Opportunity took a picture of these spherical objects, and this is an image taken about 9 years after that first image the previous image I showed you. And at first, scientists thought, well, heck, these kind of look like blueberries too. But you know what? After doing some chemical analyses and really exploring what these are, scientists don't know what they are, but they know they're not blueberries. So Mars mysteries are still out there, and we're still trying to figure out what exactly Mars's past was, how water played that role, and that's a great reason why we have our rovers exploring Mars, so we can try and figure those things out. Now, our newest rover, which has joined Opportunity in its exploration, is the Curiosity rover. And this rover landed this last August on Mars, and it's been able to do some things that our Mars exploration rovers and Sojourner haven't. And one of those things was when it landed on Mars, it basically filmed its landing. So if you guys went skydiving and took a video while you were skydiving, that's exactly what the Curiosity rover did. And here's an image. You can see its heat shield dropping away, and that's the part that keeps the rover safe from when it's entering the atmosphere. And you can see the dunes and Mount Sharp below. So that was one of the newest parts of landing on Mars that the Curiosity rover was able to achieve. We've also explored an area in Gale Crater. And here we see these rounded pebbles and this type of rock called a conglomerate. And scientists believe that looking at this image, we're able to see that these rounded pebbles were most likely formed as water flowed through this region. So now we have Spirit, Opportunity, and Curiosity all finding evidence of water in Mars's past. Along our way, as we've been exploring Gale Crater, we've stopped at a sand dune and took scoops of the soil and put them inside our rover, and we're able to find out that the soil here in Gale Crater is very similar to the soil that Spirit and Opportunity explored on different parts of the planet. And here we are sitting at a place in Yellowknife Bay, and we took a picture of ourselves because, well, I think the rover's really cute, so we like to look at ourselves every once in a while. And we're at a part called Yellowknife Bay, and we're exploring the rocks that we have below us. And here, scientists have drilled into a rock, and we've gone about 6 centimeters deep into a rock, which is the furthest any of the rovers have drilled. And right now, our science instruments inside the Curiosity rover are analyzing this material to find out what it's made of. And from the composition of this material that's in this rock, we can try and figure out what has happened in this region. But as we keep going, our main goal is to get to the base of Mount Sharp and travel up inside these canyons and explore the layers of the mountain. And so Curiosity has a long journey ahead of itself. And here we are right now where it says Glen Elg. This is where we landed, and this is where we're eventually going to travel to, is the base of Mount Sharp. So this is about 8 kilometers away, which is a shorter distance than the about 35 kilometers that Opportunity has traveled. So Curiosity has a long ways to go before we can reach the base of Mount Sharp, but there's a lot of areas along the way that are waiting for us to explore. And even in the future, we're looking forward to a mission in 2020. And just like we've designed rovers like Spirit and Opportunity and Curiosity, I'm going to ask this question to you guys, so maybe think about this as you guys continue to learn about Mars. So if you were designing a rover for the 2020 mission, what would you do different? Would you keep some of the parts of the rovers the same as the past? Would you change things? Would you put new parts of the rovers on it? Would you put new scientific instruments on the rovers? There's a lot to think about as we look to the future of roving Mars. So as we look and wait for our 2020 launch, you guys think about what this rover could be, because it sounds like we have some really great observers out there, some future scientists and some future engineers, and I bet you guys, if you really want to, could be designing this next rover. So as we wait and look for our next places we're traveling along Curiosity, we want you to stay tuned so we can share those discoveries with you, and are really glad that you guys were able to join us today as we explored our rovers on Mars. And Paige, I think we're going to do something different as we look at as we go to our question and answer session. So I'll let you describe how we're going to do this.
Okay, sounds great. So first comment is thank you, Cherie, for sharing about the past, present, and future generations of Mars. And for those of you that do have some thoughts that you want to put out there as far as things you would do the same or differently, you can feel free to put that information in the chat window. But we definitely want to make sure that we save some time for some Q&A. So for the next 10 minutes or so, we're going to actually have Cherie sort of show herself for real. But when she does that, you guys are going to lose the chat window. So I want you to pay attention for a minute so that you know how to be able to access the chat window so you'll be able to put in questions. So when Cherie shares her camera, there's sort of 4 things I'm going to ask you to do. One is if you move your mouse near the top of your screen, this little drop-down menu you can see at the top of the window is going to appear. So you're going to see that menu, and then if you click on the chat box is going to appear in the right-hand side of your screen. And just to make sure that you have successfully located the chat window when you get there, we're going to ask you to type in something like, "Hi, Cherie," so we know you're there. So hopefully you got those little 4 steps. Cherie, if you'll share yourself so that we can see you. And so she's going to share an application so you can actually see Cherie live. So again, if you move your mouse up and you have that drop-down box, you're going to see the chat window. So let us know in the chat window that you can see Cherie and you have found the chat window. So Springbank has found it, Lewis F. Meyer, Evergreen can see you, Shapley and Mrs. Voltaire's class, Eastern Illinois can see you, Showalter, Pennsylvania, they can see you, Shapley and Mr. Weatherhead's class can see you. Let's see if we're missing anyone. McClary can see you, excellent, as can Queen Creek. Good. We didn't want you to be lost without your chat window so that you can put in any questions you might have for Cherie. So we thought it'd be fun to kind of share Cherie with you this way. So if you have questions that you would like Cherie to answer, now's your opportunity to put those questions into the chat window. So let us know or put in your questions, and I'll see if I have missed any. I know that many of you were putting in information about how you might make the rovers the same or different with cameras and using past rockets and a parachute to jump off a cliff. That's an interesting one there. But we definitely want to get some questions so that we can use Cherie's expertise. So Cherie, I see a question here from Queen Creek Elementary in Arizona. Can you let them know a little bit about how big Mars is?
Sure. Hi, Queen Creek. So Mars is about 1/3 of the diameter that Earth is. So it's a lot smaller than Earth, but it has a lot of exciting things that we're trying to explore with our rovers.
Good. So it's a pretty small planet, although some of you may know it has some of the largest features in the solar system, including Olympus Mons, which for those of you in Arizona, you'd be covered by that one volcano on Mars. So small planet, but big features. Great question, Queen Creek. So Shapley School and Mrs. Voltaire's class in Maine, they'd like to know how many rocks have been collected, if any.
Oh, that's a great question. So, and it looks like you guys are wanting to know how many rocks have been collected by all the rovers. And all the rovers, actually, they aren't able to collect rocks. They can explore them with the instruments on their arm, but they don't actually collect and save rocks. Now, the Curiosity rover is a bit different. So there's a scoop and there's a drill, and we can put those samples of rocks inside our instruments that are in the body of the rover. And so in that way, we can kind of keep our rocks.
Excellent. So, and you know, thinking about that 2020 rover, is it correct to say, Cherie, that they're thinking about having that rover cache or collect rocks?
That's one of the rumors that's out there, is that they want this rover to drive along, take a rock and cache it, which means keep it within the rover, and keep going to other places. But right now, there's a team of scientists and engineers gathered, and it's called the Science Definition Team, and they're coming up with the main goals of what this next mission is going to be. So hopefully within the next month or two, we'll have an idea of what the goals of the 2020 mission will be, and maybe it will be to collect these rocks.
Should be interesting, I'm sure. So now, Shapley School also would like to know if you can tell them a little bit about how much it costs to make Curiosity and how long it took to build this very large rover.
Ooh, those are really great questions. So the Curiosity rover cost about $2.5 billion, and I know that sounds like a lot of money. I don't have $2.5 billion, but it's well spent. And so it took, my guess is probably maybe 6-7 years to build the Curiosity rover. Now, the rover itself was built at JPL, which is the Jet Propulsion Laboratory in California. But a lot of the science instruments were built in other places and then were sent to JPL to be put on the rover. And so it's really neat that we are able to bring all of these different parts of rovers and put them onto one. But $2.5 billion sounds like a lot of money, and it's actually not, because we're hoping that maybe this mission can last as many as 10, 12 years. And so if you spread that money out over that many years, and all of the science that can be performed by this rover, and all scientists around the world are able to participate and look at the data that the rover finds. So in my opinion, it's well worth the $2.5 billion.
And it's a great point that Cherie says that although it sounds like a lot of money, it really isn't, because it really is spread out over years. And in terms of taxpayer dollars, if you think about sort of that, it's pennies on the dollar that people pay in order to be able to support this type of research and type of mission. So it's not as though it's a very small amount of money when you really think about it for getting these missions and the discoveries that we're actually able to make. So thanks, Cherie. Here's another question that we have. Let's pick one from Showalter, Pennsylvania. This group, they would like to know, can you tell them how the rover is powered?
Ooh, that's a great question. So as you saw, the Sojourner Rover and Spirit and Opportunity had solar panels. But if you look at a picture of Curiosity, there's no solar panels on there. And the way it's powered is that in the back of the rover, there's a nuclear generator. And it basically has a plutonium, which as it degrades, it produces heat. And this heat is transferred into energy, but not all of it. Some of the heat is used to warm the electronics inside the rover, because it can get really cold on Mars. An average temperature on Mars is about -65 degrees Fahrenheit. I don't know about you guys, but that's really cold to me. So we need to keep everything nice and toasty and warm inside the rover. So some of that heat from the source is used to warm the rover's instruments and electronics. The others is converted into energy, which can be used to drive or do scientific measurements or to take pictures.
Great. Thank you, Cherie. Now, I do see that it is almost the top of the hour. So for some of you, if you have to depart and go on to your next classes, I want to thank you very much for participating. And I know that you probably share this with me and how much we appreciate Cherie in taking the time to share her expertise and this information with us today. However, we are going to stay on the line. If you have some extra time and you want to stay with us, Cherie has agreed to stay on the line to answer some additional questions. So stick with us. We'll answer more, but if you've got to go, thank you so much for participating. We look forward to connecting with you guys again in the future. So Cherie, I'm going to give you our next sort of set of questions from Evergreen. And they were asking a few things. One was about how can the rover take a picture of itself? Additionally, when will the rovers ever come home? And thirdly, when will we send people to Mars?
Ooh, wow, all really great questions. So the way the rover was able to take a picture of itself is just like if you guys took your own camera or cell phone or whatever you have and held your arm out in front of you and took a picture of yourself. Well, Curiosity has an arm, and there's a camera on the end of its arm. So it held its arm out and took a series of pictures and then put them all together, and that's how it was able to take a picture of itself. So it's a really cool trick, and every time we do that, it's one of my favorite pictures that I look forward to seeing. So our next question was
related to when they'll ever come back.
Oh, okay, so when they come back. So unfortunately, the rovers will never return to Earth. And once they're done, like Spirit, it will just sit on Mars forever. So maybe one day in our human exploration missions, we'll visit a similar site and be able to see these rovers. But they stay on Mars forever. And leading into that, when do you think humans will go to Mars? That's a great question. There was an original goal of 2030, but you know, that's only 17 years away. That seems really soon to me. And there's a lot of obstacles that we have to go through before we can send humans to Mars. And just like we send rovers to Mars, there's instruments on these rovers, like Curiosity has a radiation detector. So we're trying to not only explore the surface of Mars, but explore the environment and the atmosphere. So later when we send humans to Mars, we have a better understanding of the planet. So my guess, this is just out of the blue, I would say maybe by 2050 we might have someone on Mars. So we'll see. We'll have to stick around and find out.
Right, and I know there's plenty of us around this community, and I'm sure perhaps many of you there in schools. We certainly hope it happens in our lifetime because we'd really like to see humans land on Mars. And we probably have quite a few volunteers that'd be willing to go on this mission right now if it were going to happen. So someday I am sure that we are going to get there. So great answers, Cherie. We had a question from Chapley School in Mr. Weatherhead's class about curiosity and drilling into the surface. And so they're curious as to why did Curiosity only drill about 6 centimeters into the rock? Why not deeper?
Oh, that's a great question. Man, we have some smart people out there. So just like if you guys have a drill at home, there are parts called drill bits. And the length of those drill bits basically means how far you can drill into a rock. And so our drill bit is only about 6 centimeters. And so that's kind of the maximum amount that we were able to go into that rock. Now, some rocks may be really hard, and maybe we'll only be able to drill, a couple centimeters. But the rock that we explored, we were able to drill 6 centimeters into the base of it. So it all kind of depends on how long that drill bit is. And here's kind of a cool little thing. So Curiosity has 2 extra drill bits on it. And if something happens, like maybe it gets stuck in a rock, it's really hard, and we can't get it out of there, the arm can basically drop off that drill bit, and we can go and pick up an extra one. So it's really cool. The engineers were really smart in thinking ahead of different problems that we could encounter.
That's really interesting because I'm sure if you've ever worked with a drill or any of your family members have worked with a drill, boy, if that drill bit breaks, you got to replace it. And we don't have a person on Mars to do it for the rover, but the rover can do it itself. That's awesome. So Cherie, also from Chapley School, they would like to know, have any of these rovers ever crossed paths?
Ooh, that's a great question. And actually, we've sent the rovers to different parts of the planet, so they've never crossed paths. Because when we send rovers, we really want to explore new areas. And even though Mars is a smaller planet than Earth, there's so much area to explore and so many places. So it's almost like if you guys had to pick 4 places on Earth to send a rover, where would it be? Would it be in the mountains? Would it be in the deserts? Would you send one that could go in the oceans? There's a lot of places on Earth that we would want to explore. So just like Mars, it's really hard to pick those areas. So we don't want to send them to the same spot. We want to pick different places.
Yep, good representation of Mars in all the areas that we've been to, that's for sure. So North Richland Middle School here in Texas, back to this whole drill thing. Do you think, from what you know and what your knowledge is, will the 2020 rover have a drill to drill into the crust of Mars like Curiosity does?
Ooh, that's a really good point. And, you know, you saw the slides that I had for the 2020 mission, and the drawings look a lot like the Curiosity rover. So I would think that it would have an arm, just like Curiosity does, and it may be simpler, so maybe it won't have a drill. But I would think that if we were talking about earlier, maybe if the goal is to cache these samples or to keep the samples as we go, maybe one way we would want to do that is by drilling into them and to keep those powders, because the surface of Mars is covered in a layer of dust. And so once we get below that surface, there's a lot more to explore. So I hope it has a drill, because it's been a lot of fun seeing Curiosity drill into the rocks.
It sure has, and we hope to see more of that occur as well. Now here's an interesting question from Queen Creek that I want to jump to. And they're wondering there in Arizona, what's the best part of your job? And also related to that is, how many scientists are there in NASA, and does that number go up, go down? You know, has there been more now than there was in the past? So first about you and the best part of your job, and then about scientists in general and how many we might have.
You know, I think the best part of my job is working on these missions, and with the Curiosity mission. And it's Mars has so many surprises, and it's really fun to follow along and to see what exactly we find out as we scoop up the material or drill into rocks, or even as we're just driving to a place to look at all the images. So my favorite is definitely working on the Curiosity mission and looking at the data that the rover sends back every day. It's always something new, and it's always really exciting. So as for how many scientists work at Mars, or at NASA, I'm sorry, I don't think there's any scientists on Mars yet. But there's several NASA centers. So we have here the Johnson Space Center in Texas. There's the Jet Propulsion Laboratory, the Ames Research Center in California. There's the Goddard Center in Maryland, and the Kennedy Space Center in Florida, and many other NASA centers. And, you know, Paige, maybe you may have a better idea. Do you know how many scientists work there? Because I sure don't know. I know it's a lot.
I would have to agree with you. It is a lot. I would say it's in the thousands, because if we think of just how many scientists are in our one building where Cherie and I work. So we're in a two-story building. I would say maybe there's 30 offices on each floor, 30 to 50 offices. Let's say 50 for a nice round number. And there's usually at least 2 people in each office. So in our building per floor, there's 100 scientists. So that's just 200 scientists in one building. We've got a lot of buildings here at JSC. So if you think about how many scientists are within NASA, there's thousands of them. And here we might be studying planetary science or astromaterials, but we also have areas that study what we call astrobiology, or that focus on that specialize in wind tunnel research, or sending spacecraft and launching them to parts of our solar system. So every center sort of has a specialty, and there's so much science that goes along with that. So the best answer, I would say, is that there are literally thousands, but in many, many, many different areas of expertise. So let's say you like geology. Well, there's a lot of planetary geology that goes on within NASA. But let's say you like biology. Then you've got astrobiology. Or aerodynamics. We've got the Dryden Flight Research Center in California as well, and they specialize in aeronautics. So literally thousands. And we need you guys as our next generation of scientists and explorers.
I agree.
So I saw a question from from Shapley School and Mr. Weatherhead's class, and they were asking how these rover names are picked. And I'll add to that, how are these rover locations, Yellowknife and things like that, how are those names picked? So can you answer to both of those?
Sure. So the names are always interesting of the locations we're at. So right now where Curiosity is exploring is a place called Gale Crater, and that's on Mars. But everything that we're naming, so each rock that we explore, each area, right now we're in Yellowknife Bay, all of these names are taken from a research area in Canada. So it's really neat that the scientists who are working on the mission actually look to places here on Earth for what they want to name on Mars. So this area in Canada has a lot of significance and even some similarities to where we're exploring on Mars right now. As for the name of the rovers, all right, guys, listen up, because this is very relevant to you guys. Each rover has been named by a student, and they hold a contest, and you basically say, I want the rover to be named Curiosity because, and you write an essay that explains what you think the rover's name should be. And the NASA headquarters goes through all of the entries, and there's a winner picked. And that winner, like with Curiosity, was able to sign the rover, and her signature is on Mars right now, and also was able to attend the launch and to attend the landing parties too. So just like you guys out there could name this next 2020 rover mission. So stay tuned and come up with some good ideas from now until they put out the call for naming the next one.
That sounds like a great plan. And, you know, with those rover location names, I believe they are sort of unofficial in that there's actually a group that helps to officially name, whether it's a crater or on Mars or different areas. So there is an official way to name locations or rocks on Mars, and then there's the sort of unofficial way to help sort of give context to what they're looking at. Because if nothing had a name, it'd be like Rock A. That doesn't say anything. But if you call it a location, then it really starts to almost develop and helps you remember the characteristics of whether it's the rock or whether it's a location. So those are really, really great questions and a great answer there, Cherie. So here is a question from, actually from Eastern Illinois University. They would like to know, Cherie, what kinds of classes in high school and what majors in college should students choose, especially these students on the line as they think in the future, to best prepare them for careers involving the exploration of other worlds like Mars?
Wow, that's a good question. And I'll tell you, I didn't take the typical path to being here at NASA. When I was in college, I really liked engineering. And so I took a few engineering classes, but it just wasn't right for me. And so I switched to biology because in high school, I really loved science. And I had a great biology teacher, and it was just thrilling to me. So I loved science, and I loved trying to find out, you know, how things work. And so when I was in college at the University of Arizona, I majored in molecular biology. Well, it's a mouthful, but that's what I graduated in. But through an internship, and I really suggest all of you guys out there look at the different internships, especially in high school and in college. There's so many different things you can get involved with. And since I liked space, I really decided that this internship was a great way to kind of get involved in that. And so through the internship, that's when I was put on the Phoenix Mars mission. And after that, you know, I just really started to love Mars. But now that I'm here at the Johnson Space Center, I'm back in school again. So I'm kind of a lifelong school person, and I'm taking classes in geology. And so geology is really great. Whether you're, you know, we made a lot of comparisons to Earth today. Like we saw the clouds and the meteorites and the rocks, and there's a lot from Earth. So even if you're doing Earth geology or terrestrial studies, you can apply a lot of those same concepts to what we're exploring on Mars. So whether it's any science, any chemistry, biology, geology, all those sciences are relevant to Mars, as are engineering, whether you want to be an aerospace engineer, a mechanical engineer, an electrical engineer. All types of engineering are involved in the exploration program in making these missions and making them run. So it's really the sky's the limit with what your major can be. And just pick something you really enjoy, because that's what's really important as you go off to college and as you're looking at classes in high school to take, is to really take those things that you really like.
And to just sort of add to that, you know, if you like education, NASA has a place for educators. If you like graphics or making videos, NASA has a place for that as well. So never close the doors to the things that interest you, and always look for those opportunities where you can sort of blend what you like to do and how you can make a career out of it. So great question there from Eastern Illinois University, and I'm sure some of your university students are even probably struggling themselves and thinking about what classes and what should I major in.
I've been there. I feel you.
Well, in North Richmond Middle School is one of our middle schools remaining on the line, and they're here in the Texas area. And they were wondering, Cherie, if you could go to Mars, where would you go?
Ooh, that's a great question. I think if I were to go to Mars, there's a region called Mars Vallis, and it was one of the candidates for where Curiosity was going to explore. And it's near one of the biggest canyons, actually one of the largest canyons in the solar system. It's about, you know, if we look at the Grand Canyon, we think that's big here on Earth, but this canyon is called Valles Marineris, and it stretches the length of the United States, so it's a big one. But just around there, there's a region where there's a lot of different types of minerals that the scientists have been able to use cameras and different types of instruments from orbiters to see what the diversity is down there. And so I think it's really neat to see all the different types of minerals, and it would be a big challenge if I were to go to Mars. That's where I would want to go, because it would be a challenge to try and figure out what exactly happened there in the past.
And it is interesting to think about with that 2020 rover, besides all of what they're going through right now and to determine what types of scientific instruments and what they will, you know, sort of have this rover be capable of doing, they'll also have to go through that process of where to land that rover. And there are plenty of scientists, just like Cherie, that are interested in checking out Valles Marineris. It's kind of like, you know, going into our Grand Canyon. You know, you can't just get there and look at it from above. You want to go in. And so North Richland, it's a great question, and it's one that scientists are definitely going to be debating as we get closer to the 2020 Mars rover mission. Now, we have just two groups left on the line, so you basically have sort of the floor to ask any other questions you might have. And North Richland, I don't know if I missed any of your questions that you might have typed up earlier, but let us know in the chat window if you have any other questions for Cherie, and the same thing for Eastern Illinois. If you have any other questions for Cherie, we'll give you sort of our last call for questions from the expert. So let us know if you have any questions, or if you don't, let us know that as well. So we'll give them a minute there, Cherie. You know, now I'm curious, as they might be typing in whether they have questions or not, I wonder how many offices we have in our building to know how many scientists we have in this building, because that was a real estimate on my part.
I think it was a good estimate, but I've been wondering that ever since, too.
I'm going to go around and start counting the doors and then seeing how many people are in each of the offices.
Sounds good. You take the top floor, I'll take the bottom.
That sounds like a plan. Well, I'm not seeing anything else come in. Eastern Illinois has said that doesn't look like they have any other questions, but North Richland did ask, what would you name 2020 Mars rover?
Oh, man. I haven't given that much thought because I think I'm a little too old to enter the contest. But, you know, I think Curiosity was a great name because it really defines, you know, why we're on Mars. And so we're curious about the surface and curious about learning. So if I were to pick a name, it would probably be something that describes why we want to go there. God, I can't come up with something off the top of my head, but that's something that I'm definitely going to think about today.
Yeah, and it really is, I think a lot of it really does have to go along with what are the goals for sending this rover and what's the latest that's going on. You know, is there something in particular that they're going to try to do with that rover, or some new discovery that's going to be made that rover is going to further investigate. So a lot of sort of that context might help drive the name for that rover. So hopefully by the time we figure we're in 2013, so 7 years away. I don't know what the age limit is. And for the North Richland Middle School students, hopefully you're still within that age range to be able to help name that 2020 rover, because it sure would be nice to have a Texas person be able to name that rover in the future. And so North Richland Hills in Texas. I think that's near the Dallas area. Is that, or Austin area? What's the nearest sort of big city for you guys, North Richland? Fort Worth area. So yeah, it'd be really cool to have someone from Texas in the Fort Worth area, or even our Houston area, someone at least from Texas. We're a big state. We can get somebody to win that contest, so we hope it's one of you guys.
I agree. That's a good plan, Paige.
Well, if there are no other questions, we really, really appreciate your time. We're so glad that you were able to join us, especially from Eastern Illinois, still on the line, as well as our North Richland Middle School group there in the Fort Worth area. We're so glad that you could join us today, and we really look forward to having you join us again in the future. Cherie, thank you so much for sharing your knowledge as well as sharing you with us. I'm sure it's been fun to kind of be able to see you in person there. So any closing remarks for our groups that are still on the line?
I just say thank you and thanks for hanging around. It's been a lot of fun, and I love being able to share, you know, what Curiosity has found and what we found in the past. And so it's always exciting to me. So I hope you guys join us again, and just thanks for joining in with us today.
Great. Well, thank you again, Cherie. And I guess with that, we'll sign off. Thank you, Eastern Illinois. Thank you, North Richland Middle School. Until next time. Bye-bye, everyone.